third graders, today in math, we're going to do part 2 of lessons 11 to 13. So we're going to continue what you started yesterday. We are going to compare unit fractions with different sized models representing the whole. So, for example, I can look at 1/2, but I have to see 1/2 of what? 1/2 of a cookie is different from 1/2 of a whole cake. Then we're going to specify the corresponding whole when presented with one equal part. So if you have this triangle, okay, here it is, this triangle, and I tell you that this is half, can you draw the whole? Yes. If this is half, I need to draw 2 of these to have the whole. If I tell you that this is 1/3, then I need to draw 3 of them to have the whole. Okay, so if I'm presented with a fraction and I'm told what fraction that is of the whole, I can always draw the whole. Okay, and the third thing that we're going to look at, which is a little bit tricky, is I can identify a shaded fractional part in different ways depending on the designation of the whole. Now, this is a little bit tricky. We're going to look at it today in this lesson. And we're going to see how a shaded part is different depending on what we designate, what we consider the whole. Okay, but we'll see it in more detail. Okay, first, let's look, because I noticed that this is a little bit tricky, units that are more than one whole, okay? So what's 1 more fifth than 1 whole? Okay, so you have to always think. A fifth, you're looking at the denominator, okay, 1/5. The denominator shows in how many equal parts I divided the whole. So if I have a fifth, it means that I divided my whole into 5 parts. And if I take them all 5 parts, I'm taking the whole. So 5/5 is 1 whole. What's 1 more fifth? Well, of course, 6/5. 6/5. All right. Let's try another one. Try to answer these questions before I give you the answers. Try to answer them with me. What's 2 more fifths than 1 whole? So again, think, what's 1 whole? 5/5. Okay, I divide the whole into 5 parts. I take all 5 of them, so 5/5. Numerator is the same as the denominator. What's 2 more? 5 plus 2 is 7. So 7/5, 7/5. I divide my whole into 5 parts and I take 7 of them. Now you're wondering, how can I take 7 if I only have 5? Well, obviously from a second whole. Okay, remember, I think we saw that in a problem with cakes. Okay, so you have 1 whole cake, you divide it into 5 parts. If you want 7 slices, you have to have another whole cake. Okay, what's 1 more tenth than 1 whole? Pause, try to answer this question. 11/10. So 10/10 is a whole, 1 more is 11/10. What's 5 more eighths than 1 whole? Pause, think. 1 whole is 8/8. So we're looking at these eighths. It means I divided my whole into 8 parts. Here, tenths, I divided my whole into 10 parts. Fifths, I divided my whole into 5 parts. So 8/8 is 1 whole. What's 5 more? 13, okay? 8 plus 5 is 13/8. 13/8. The numerator is 13. That's how many pieces I'm considering. And it's more than 1 whole. All right, now, let's see if you can do this with me. Sorry, let me get this card. Okay, fold a card to make 4 equal units. Okay, so we have one whole card. Okay, and we're going to make 4 parts, 4 equal parts. Okay, so you fold it in half and then in half again. Okay, so that's fourths. And we're going to, it says shade and label the first unit. I actually labeled all of them. Okay, so I shaded in 1 part. Okay, I labeled them all. I divided my whole into 4 equal parts. So each of these is 1/4. And I shaded in 1/4. Okay. Each part is equal to what fraction of the whole? Okay, we just said it. Each part is 1/4 of the whole, because I divided the whole into 4 equal parts. Each part is 1/4. Okay. What is the whole? The whole card. Okay, it's not an index card, but anyway, the whole strip is the whole. Okay. So one card is the whole, and I divided it into 4 equal parts. Now, with a black marker, trace the outside of your card to show the whole. I already did this with this black marker. I traced around to show the whole. Now you're going to understand why. Okay. Now, flip your card over so you cannot see the fraction you wrote. Okay. Now, the new whole is half of the card. Outline it with the marker. So as you can see, okay, right here, half of the card is my new whole. Oops, there we go. Half of the card is my new whole. And I traced the outline with a marker. And then use your pencil to shade the same amount of space you shaded on the other side. So see, on this side, I shaded this. And I'm going to shade it on this side. Okay, let me do it here too. There we go. I shaded it. So I shaded the same portion of the card that I shaded on this side. Okay. Stop and think about how to label the shaded amount on this side of the card. So pause and think, how am I going to label this? Okay. So think about it. Here I had the whole card, divided into 4 parts. I shaded one of them and I labeled it 1/4. Now I turn it over. This time my whole is this part here. I shaded the same part, okay, the same piece, but how am I going to label it? Am I always going to label it 1/4? Okay, so if you said that you're going to label it 1/2, you're right. I'm not going to label it 1/4 because if this is my whole, the shaded part is now 1/2. So I'm going to go ahead and write 1/2. Okay, 1/2. And actually, I think you can see it better on this model than on the one on the screen. Okay, because I can clearly see that now this is my whole and the shaded part is 1/2. What does this teach us? Okay, half the card is the whole. So half of a half, which before was 1/4, but if half is the whole, this is, this is 1/2. Okay, changing the whole changed the unit fraction that we used to describe the shaded part. What was 1/4 of the whole card, this part here, is now half of the new smaller whole. Okay, so before I had the whole card was the whole, and this was 1/4 of the whole. Now my whole is half of the card. So this is now, it's always the same. See, it was 1/4. Okay, and now the same part is half because the whole is different. So you have to always remember that when you're comparing fractions, you can compare them if they are related to the same whole. So if the whole is the same, we can compare fractions. If the whole is different, then we cannot compare them. Okay, let's look at this problem. For his birthday, Kyle's mom brought in cake to share with the class. Sorry about these. Well, you'll see later why they're there. When she picked up the 2 cake pans at the end of the day, she said, "Wow, your friends ate 3/4 of the cake." Kyle said, "No, Mom, we ate 6/4. Stop and think who is right. Okay, stop and think. So these are the 2 pans of cake, one whole pan and the other whole pan. Okay, Mom says your friends ate 3/4 of the cake. Kyle says, "No, Mom, we ate 6/4 of the cake." All right, this is one whole cake divided into fourths. Okay. If each cake pan is one whole, then we have 4/4 is one whole, 5, 6. So Kyle is correct. 6/4 were eaten, right? 4/4 is one whole cake plus two more from a second cake. 6/4. However, like in this example with the card, however, if the whole is both pans, so see, I put a frame around it. If the whole, if we consider both pans the whole, then, and I divide the whole into fourths again. So 1, 2, 3, 4/4 is the whole. So this time both pans are the whole. So what fraction was eaten? 1, 2, 3/4. 3/4 of the pan were eaten. Okay. Okay, so this will be your work for today. You have 3 slides, 3 worksheets. Here, each shape represents a unit fraction, and you have to draw a picture representing a possible whole. Okay, so you have 1/7. You have to draw the whole. Now, remember, look at the denominator. You have 1/7. So we're talking about sevenths. That means that the whole has been divided into 7 parts. So I need to have 7 of these parts. This is one of them. I need to have 7. So here it says you can drag the shape to make your design. You can rotate the shapes too if you need to. So you can drag them, rotate them. Just remember, think this is one of the 7ths. How many do I need to make a whole? Same thing here. Here I have 1/9. So I have a square. And the problem is telling me that this square is 1/9 of the whole shape. Okay. Remember, the point is that I will need 9 of those. How I decide to make my design, how I decide to design my whole is not important. The important thing is that I have 9 of those. 9/9 make a whole. Okay. And here there's a little problem for you, and you have to say if one or the other solved it correctly, or maybe both of them. On this slide, you have 3 different racks: rack A, rack B, and rack C. And they are being compared. So it's saying that one rack is about half of rack C. So you have to figure out which rack is about half. And then there's one rack that is about 1/3 of rack C. So you're comparing them and seeing if one is a fraction of the other. Okay, and on this last one, you are comparing, we're trying to compare fractions, but the wholes are different. Remember, we talked about it with our fraction strip, with our strip here, our strip of card. If the whole is different, we can't compare the fractions. So here I have half of a small pizza. It looks like a cookie, actually. Half of a small pizza and 1/4 of a big pizza. Can we compare them? Can we say that one is bigger than the other? That's for you to answer this question. Remember, the wholes are different. And again, here we have 2 candy bars. They're different candy bars. 1/2 is shaded. So can we say that they're both the same, that Manny and Daniel are eating the same amount of candy because they're both eating half? That's a question for you to answer. Look at the wholes and decide, are we talking about the same whole? So can we compare? Can we say that they're both eating half, so they're both eating the same amount? All right. Reach out to your teachers if you need help. I know things are getting a little bit tricky, but I hope you are enjoying fractions. And remember to keep looking for fractions inside your house and in your everyday life, especially in the kitchen. I mean, when you're eating, it helps, but also when you're playing with a friend or with a sibling or with a parent, always keep this idea of wholes and fractions in mind and see how you can discover things, experiment with fractions. All right, bye kids.